Sometimes the best stories in paleontology, they start with a bit of a puzzle.
Mm-hmm.
Imagine finding a dinosaur that looked like it could challenge, the big Jurassic predators.
Right.
But then you realize it's actually from the late Triassic, way earlier. That was kind of the initial buzz around this fossil called Ahliwalia rex.
Yeah, that name definitely caused a stir.
Totally. Okay, so let's really get into this because the real story here about Eucnemesaurus and how it got tangled up with Ahliwalia, it's a great example of how science figures things out.
Absolutely. Today, we're doing a deep dive into Eucnemesaurus. It's a late Triassic dinosaur. And yeah, its identity got seriously confused with those early Ahliwalia interpretations.
And you shared some great sources, bits from scientific papers and encyclopedia entry. They really lay out the journey.
Exactly.
Yeah.
They help trace how we got from that initial confusion to, well, where we are now.
Right. So our mission for this deep dive is pretty clear. Figure out Eucnemosaurus's discovery, its classification, how its bones got mistaken for this like super predator Ahliwalia rex. And, what does this whole mix-up tell us about early dinosaur evolution? So let's start with the basics. Who or what was Eucnemosaurus?
Well, the name itself is a good starting point. Eucnemesaurus. It basically means good tibia lizard.
Good tibia, like shin bone.
Exactly. It refers to its shin bones, the tibiae, which were pretty robust, pretty strong looking. It was named way back in 1920 by Egbert Cornelis Nicholas van Hopen.
Van Hopen, okay.
And the first species he named was Eucnemosaurus fortis. Fortis is Latin for strong. So again, probably nodding to those sturdy legs.
And this wasn't just like a single tooth they found, right? There was more to it.
Oh yeah, definitely more. The holotype specimen that's the original one used to describe it, catalog number TRM 119, it's a partial skeleton.
Ah, okay.
Van Hopen found some vertebrae, part of a pubis that's a hip bone, a femur, the thigh bone, and those two distinctive tibiae.
And where did this come from?
This was all unearthed in South Africa for the
Yep.
Upper Triassic, Lower Elliott Formation. So we're firmly in the Late Triassic period with this dinosaur.
Late Triassic. Okay, that's a super important time for dinosaurs starting to, diversify. So where does it fit in the grand scheme of things, family tree-wise?
Right, so scientifically it's a dinosaur, obviously. Within Dinosauria, it's a Saurischian, one of the lizard-hipped dinosaurs.
Okay.
And then more specifically, it belongs to sauropodomorpha. That's the lineage that, eventually led to the giant long-necked sauropods everyone knows.
Like Brontosaurus and Diplodocus, that group.
Exactly that group. But Eucnemesaurus is much earlier, from the beginning of that line. And even more specific, current thinking, especially thanks to Adam Yates's research, puts it in the family Rheohisauridae.
Rheosauridae. Okay.
Yeah, alongside another Triassic sauropodomorph called Rheohisaurus.
Oh,
Oh, and there's actually a second species now recognized too, Eucnemesaurus and texonsis.
so basically it's an early cousin of the giant longnecks, part of that whole sauropodomorph branch.
You got it. An early player in that key group.
All right, so that paints a picture of Eucnemosaurus itself. But now we get to the Ahliwalia connection, and this is where things get, well, confusing and kind of exciting.
This is the twist, yeah. Fossil material that we now know is mostly Eucnemosaurus was actually first given a completely different name, Ahliwalia rex.
Ahliwalia rex sounds impressive.
It does. The name Ahliwalia came from the Aliwal Park Reserve in South Africa, where those first bones were found. And interestingly, some of the very same bone types found for Eucnemosaurus, like femur bits, vertebrae, were also part of those initial Ahliwalia finds.
But the Ahliwalia evidence was much patchier at first, wasn't it, compared to the Eucnemosaurus skeleton?
That's a really important point.
Yeah.
Yeah, the early stuff labeled Ahliwalia was very fragmented. For a long time, it was mainly just some pieces of femur, the thigh bone, and crucially, a maxilla, part of the upper jaw.
A maxilla, okay.
And get this, some of that material was actually sent over to Austria way back in 1873, mixed in with some prosauropod bones. So it was a bit of a jumble from early on.
Okay, so fragmented bones, including a jaw piece. And that combination led to a pretty wild interpretation, didn't it?
Oh, absolutely wild for the time. The femur fragments suggested, a pretty big animal, but it was that maxilla, the jaw fragment, that really lit the fuse.
Why? What was special about it?
Well, it seemed to have teeth, or sockets for teeth, that look carnivorous, like a meat eater's jaw.
Ah,
So you have big leg bone pieces suggesting size, and a jaw piece suggesting it ate meat. And this is the Triassic we're talking about.
right. Not when you expect giant predators like T-Rex or Allosaurus.
Exactly. So the idea popped up. Could Ahliwalia rex have been a huge, maybe Allosaurus-sized predator, but living millions of years earlier in the Triassic? That was a very exciting prospect for paleontologists.
Wow, okay. I can see why that would cause a buzz, a Jurassic super predator.
Precisely. It challenged the picture of what Triassic ecosystems were like. And this initial interpretation, though we now know it was wrong, it really highlights how people were trying to piece together the early days of the dinosaurs. The later correction actually helps us refocus on just how important the sauropodomorphs were becoming back then.
So for a time, the scientific thinking was that Ahliwalia was maybe some kind of early giant theropod. Did they try to classify it?
They did. Peter Galton, a big name in paleo, initially put Ahliwalia into the Herrerasauridae family.
Herrerasauridae, like Herrerasaur.
Exactly.
Yeah.
At the time, Herrerasaurus itself was often considered a very early, primitive theropod. So classifying Ahliwalia there fit the narrative. A large, primitive, carnivorous dinosaur from the Triassic.
Okay, the plot thickens, but science marches on, right? Things get re-examined.
Thank goodness they do. And this is where Adam Yates's research, published in 2006, becomes absolutely critical. It basically turned the Ahliwalia's giant carnivore idea on its head.
What did Yates figure out?
Okay, so Yates did a couple of key things. First, he argued strongly that Eucnemesaurus, which some had kind of ignored or lumped in with another dinosaur called Eucnemesaurus, was actually its own distinct, valid genus.
Okay, step one, Eucnemesaurus is real and distinct.
Step one. Step two was the bombshell. He showed that the main skeletal bones that had been called Ahliwalia, Rex the vertebrae, the hip fragment, those femur pieces, the tibiae, they actually belonged to Eucnemesaurus.
Whoa, so Ahliwalia rex, the supposed monster predator.
It was mostly just Eucnemesaurus, the good Tibia lizard, an early sauropodomorph. Ahliwalia rex is now considered a synonym of Eucnemesaurus fortis.
That's a massive correction. So what about the jaw, the carnivorous maxilla?
Ah, the smoking gun, or perhaps the red herring. Yates's analysis showed really clearly that the maxilla simply did not belong with the other bones.
It didn't fit.
Didn't fit at all. It was definitely from a carnivore, yes, but a different dinosaur altogether. It wasn't part of Eucnemesaurus.
So the original Ahliwalia material was a chimera, a mix of two different animals.
Exactly. A classic paleontological mix-up. You had the sauropodomorph bones, Eucnemesaurus, accidentally lumped together with the jaw of an unrelated Triassic carnivore.
It's amazing how one rogue bone fragment could lead the interpretation so far astray. That jaw piece really shaped the whole narrative.
It really did. And, further fossil discoveries since then have only strengthened the case. New material found clearly shows Eucnemesaurus has sauropodomorph features, consistent with that lineage.
Not Herrerasaurid or other early theropod features.
Nope. And that solidifies Yates's placement of Eucnemesaurus back into that Rheosauridae family, firmly on the sauropodomorph branch.
Okay, so this whole saga, Eucnemesaurus, Ahliwalia, the mix-up, what are the big lessons here? What does it tell us about digging up dinosaurs?
Well, I think the first big takeaway is just how tricky it can be working with incomplete fossils, especially from that early period, the Triassic.
Yeah.
Dinosaur evolution was really taking off, lots of experimentation happening, but often we only have bits and pieces. It's easy, as this shows, to put the puzzle together wrong when you don't have all the pieces.
It really drives home how important reevaluation is in science, doesn't it? You can't just discover something, name it, and assume that's the final word.
Absolutely. Science is fundamentally about that continuous process of testing, re-examining, and revising. The Ahliwalia story is like a textbook example. An established idea that giant Triassic predator got completely overturned by looking closer at the old evidence and finding new clues.
It also feels like a bit of a cautionary tale, maybe, about not jumping to the most exciting conclusion too quickly.
I'd say so, yeah. The idea of a Triassic superpredator was definitely exciting, very compelling. And maybe that excitement slightly overshadowed the inconsistencies, like how that one jawbone didn't quite fit the rest.
So be thrilled by discoveries, but stay critical.
Exactly. Maintain that healthy skepticism. Always be willing to question and revise based on the actual evidence. That compelling narrative can sometimes, pull you off course if you're not careful.
Okay, so just to quickly wrap our heads around this journey, we started with Ahliwalia rex, this phantom giant predator from the Triassic. But rigorous reanalysis, mainly by Adam Yates, revealed that most of those bones actually belonged to Eucnemesaurus, the good-to-be-a lizard, an early sauropodomorph.
Correct.
And the carnivorous jaw that caused all the confusion. That was from a totally different dinosaur mixed in by mistake. It's a fantastic story about how science corrects itself.
It truly is. It shows the process in action. Initial ideas, exciting finds, but then careful study, new data, and ultimately a much clearer, more accurate picture of life in the Triassic. It highlights the importance of anatomical detail and not getting swayed by just one piece of evidence.
It really makes you wonder, though, doesn't it? What other fossils sitting in museum drawers, maybe labeled as one thing for decades, might turn out to be something completely different if someone looks again with fresh eyes or new techniques? Could there be other mistaken identities waiting to be uncovered?
It's almost certain there are. The fossil record is full of mysteries still. That's what keeps paleontology so dynamic and, frankly, so exciting. There's always more to discover and more to rediscover.
A great thought to end on. Thanks for taking this fascinating deep dive with me.
My pleasure. It's a great story.